Hi, everyone. So first of all, I would like to say thanks for coming to my session. In this session, I would like to share our my research with my colleague Vincent, with topic sentiment analysis on feedback of higher education teaching conduct, an empirical evaluation of methods. Okay, let's start. First of all, I would like to briefly talk about sentiment analysis. What is this? So sentiment analysis is method or task to cluster or classify intents or opinions within an unstructured text. So for example, this can be about classifying people's opinion that they wrote on feedback about a product. So for example, when people sell something, so they want to understand how people review about the product. So if based on the product, they can evaluate. A product can have many customers. So for example, let's say I'm selling this simple pen. Okay, I'm selling a pen. And about 1 million users already bought the pen and provided feedback. The feedback usually in an unstructured text. Okay, so imagine if the seller want to know how their customer think about the pen. Okay, if it's good, they can keep selling it or perhaps improve the price. If it's not good, maybe they then need to evaluate the products, right? So doing it manually will take a lot of time and of course a lot of resources and therefore very expensive. Okay, now, and that's why this task has been proposed to be done automatically. Okay, now in terms of task type, there are two types of sentiment analysis task type. The first type is often called as classification task, and the second one is clustering. The main difference between these two task types is that in classification tasks, the classifier intends to classify text into a set of predefined groups. For example, pros and cons, or positive and negative. Okay. On the other hand, clustering intends to groups into unknown groups. So the clustering classifiers, not classifiers, the clustering method, the clustering algorithm aims to cluster based on certain features in the text. Okay, and this can result in as much as groups possible. Okay, and the groups is not predefined. It can be like anything. Okay, based on the user feedback. Okay, now in this paper we focus on the first one, and which is the classification task. Okay, the case study. In here we use case study to classify student opinions on teaching conduct in the University of Surabaya, Indonesia. Okay, for this case, in this case study, opinions were collected when students fill an online questionnaire as evidence of attending lecture sessions. As we know, in the past 1 or 2 years, I think there has been a global pandemic around the world, where at least in Indonesia, most of us is like, well, not most of us. I think all education provider need to go online. Okay, that is starting from the kindergarten into the higher education like University of Surabaya. So having said that, we move everything online, including we move the attendance system also online. Previously, when we need to attend a class physically, as usual, we distribute attendance form, and students can just sign their name, and then that will be the evidence that they attend a class. Okay, now in this pandemic era, we need to move that online. Okay, we need to move that online, and in that online system, students were asked to fill in a questionnaires about the teaching conduct as evidence that they actually attend the class sessions. Okay, now let's move on. The online questionnaire UI looks like this. This is actually the mobile UI. So on the very top, the students were asked about the how the session is timed, whether it is timed properly, less than schedule, or longer than schedule. Okay, and then it asks about the topic, whether the topic is relevant as schedule. The materials, whether the materials available in the UBAYA online learning platform. And finally, students were asked to write feedback on the class session, okay, on the teaching session. Now, this last bit over here, where students have a text box to put in feedbacks, is actually the one that we use as data collection in this research. Okay, so here students were asked to write an open-ended feedback on how the lecture sessions went. Okay, this is an open-ended text. So basically, students can type in anything here, or maybe nothing. Okay, so this text box is actually not mandatory, so students can just skip and have no opinions on the class. The good thing about this one is that students who wrote in here wrote it like because they want to, not because they have to. Okay, with hope that the data collected in here will be in better quality, in a sense, because they're not forced to do it, because they simply want to put feedback. Now, the objective of this research is to answer these questions: how to better understand students' sentiments or opinions on teaching conducts based on their feedbacks. Okay, as we know before, the feedback are free text. Okay, so it's quite challenging if we have to keep like monitoring each feedback manually. It will be great if we can somehow automatically evaluate how the teaching went. Okay, especially from the dean or the university perspective to evaluate teaching conducts in this university. In terms of contributions, in this paper, we provide the following contributions. First is the evaluation on impact of text preparation methods on accuracy of sentiment analysis methods. Second, our second contribution is evaluation on the accuracy of 3 general sentiment analysis methods: the naive Bayes, support vector machine, and decision tree. Finally, we also evaluate the accuracy of combining results of the 3 sentiment analysis using vote mechanisms. So on the third one, specifically, we think, hey, instead of contrasting or competing the 3 methods, what if somehow we can combine results of the 3 and see if we can use the combination to provide a better, or in this sense, more accurate classification. All right. Now, first, we do our lead review, and based on the paper by Alicia et al., we found that there are 5 steps in data analysis. First being data collection, followed with text preparation, sentiment detection, sentiment classification, and presentation of output. Let's talk about each of these one by one. First, data collection. So in terms of data collections, there are actually many data. So this is the first step where we first collect data that we want to work on, we want to analyze. And in terms of types of data, there are two types of data, be it primary or secondary data. The primary is when the data collected is specifically collected to fit a research purpose. Secondary data is when the data used is actually collected for other purpose, not specifically for this research. And having said that, in this research, we focus on using secondary data, which is a text and unstructured. As we know, as I explained before, the data collection is not for this research only. The data is collected actually to provide or as a means to record students' attendance, not for this research, and therefore we consider it as a secondary data. After we get the data, the next step is to prepare the text, to prepare the data collections. Okay, in most cases, we cannot just simply use the data collected and then just do analysis, because data may not be clean and data may not be in the format that we can process to analyze. All right, and in this process, this includes removing incomplete data, removing spams, special characters, and so on. So in here, we perform lower casing, stemming, and stop words removals. By lower casing, we mean we convert every characters in our data collection into lowercase. In that sense, we no longer have differentiation between capital case and lowercase, which is quite common to do in data analysis. With stemming, we convert words into its basic words. So for example, in English, for example, the word running, the basic word is run. So we convert every non-basic word into its basic words. So running, we convert into run. Writing, wrote, written, and so on is convert into write. Okay, so any variation of basic words will be converted into the basic word, which means that they will be treated as the same word. Okay, so like running, run, ran, all of those words will be considered as equal. So that's the idea of stemming. Finally, with stop words removal, is the idea is basically to remove words that are too common, in the sense they become irrelevant to detect or to distinguish a document from another document, in a sense, because that stop words is too common. So example of stop words in English includes like an, in, on, and, or, and so on. In Indonesia, that includes like dan, atau, di, and so on. Those words becomes insignificant because it simply appears everywhere. Okay, it doesn't mean anything, in a sense. If a document contains, if a text contains in, it doesn't mean that it is positive or it is negative. Okay, it's not contributing to the intention of that document. Okay, because both negative or positive intent may use that same word. Okay, and therefore it's quite common for researchers to remove stop words before we perform data analysis. Next step, sentiment detection and classifications. Here, this is the actual classification. This is the actual classification process. So in here, as I mentioned previously, this step aims to detect the polarity of sentiments into contrasting groups. For example, negative, positive, or neutral, good or bad, and so on and so forth, pros and cons, etc. In general, there are three main analysis approaches, sentiment analysis approaches, that includes machine learning, lexicon-based, and hybrid. Okay, and in this paper, we use and compared the effectiveness of three supervised machine learning methods, which are the naive Bayes, support vector machine, and decision tree. Okay, and in terms of polarity classification, we use two different classes, positive or negative. We don't have neutral. Now, in terms of evaluation and presentation of results, here we focus on evaluation results as in terms of accuracy. So when we spoke of effectiveness or performance, we speak about accuracy. Okay. In terms of data validation, we use the k-fold cross-validation, and this is simply because we found this is okay in term, and it is comparable to other validation method such as the holdout validation. And we will talk about each of these methods that we do in this research now. All right, methods. Let's move from lead review to methods. This is what we actually do and what we actually have in our research. Okay, so in here, hang on. In here, for this study, we collected data from the 30th of April 2021 to 11th of May 2021. So it's quite recent. And initially, we collected 60,655 data. Then, as part of the data preparation, we scrubbed this initial data by removing feedback with less than 2 characters. This can be like a space, just whatever. Okay, we consider this one as irrelevant. Of this 9,076 data, we remove duplicates data because that is irrelevant. And then from this, we get 3,601 unique feedback. Finally, we remove feedback that wasn't related to the teaching conducts. So this irrelevant feedback is sometimes including feedback on the systems, okay? Because this system is relatively new, sometimes it's just like there's a glitch and some students having difficulties to access it and so on and so forth. We consider that one irrelevant to the teaching conduct and therefore we remove them, okay? And finally, we got the 3,570 documents or feedback in our collections. So this is our final count in our data collection. In terms of characteristics, the average word count in our data collection is 9.13 words. Having said that, the average is quite long for feedback, because think about it, some students simply said, okay, O and K, just 2 words, just 2 characters, okay? And that cause the standard deviation is also big, which is 8.37 words, okay? So the some students are keen in writing long feedback, and some are just simply say, okay, keep it up, all good, and so on. Next. Labeling. After we get the 3,570 feedback, me and Vincent manually label each of these feedback, and we divide the feedback into two. Okay, so but we also measure our agreement level by redundantly labeled 198 feedback. So from this feedback, we found that our agreement level is 97%. So 90% for 97% of the 198 feedback that we label together, we both provide the same feedback. Okay. For the 3% where there's a disagreement, we use label as provided by the first author. Next, in terms of text preparations, as I mentioned before, we use stopwords and we remove stopwords and also convert the words into the basic roots using stemming tools as provided by the Sastrawi project. Here we use the Python library version 101. Next, sentiment classifications. Before we implement the naive bias and the support vector machine and the decision tree, we first weigh the importance of tokens or word in our data collections. So in here, a token, we use unigram, okay, as our tokens. The weight of a token is considered using the TF-IDF score, term frequency inverted document frequency score. The TF-IDF score generally signify the importance of the token in the sense that token with higher TF-IDF score generally considered as more important than those tokens with lower TF-IDF score. For evaluation, we mentioned that we use the K-fold. So in this research, we use K equal to 5. In that sense, 80% of data is used for training and the remainder are used for testing. Right? Let's move on to results. Now, first of all, we want to talk about the impact of text preparations. We want to know whether implementing or applying text preparations, in this case, whether applying stopword removal and stemming actually helps. Okay, so in here we represent stopword removal with SW code and stemming with ST, and SW plus ST means we apply both stopwords and ST. So in here, NP means we don't apply anything. So this is just the plain initial data. Okay. So when we perform automated classifiers using all three automated classifiers that we consider in this study, our research shown that actually processing based on the original text make all these three classifiers works better, in the sense it produces more classification accuracy. Okay, the accuracy is higher when we ask all these three classifiers using the original documents. NP, no processing. Okay, without preparation, no preparation, no stopword removals, no stemming whatsoever, just process as it is. Okay, as we can see here, the bold in here suggests that it is the best in terms of accuracy compared to the other, and this is generally true for all methods. This is quite surprising. Maybe this means that there is room for improvement to the stopword removal algorithms or collections, and also for the stemming algorithm. Okay, maybe if we improve or if we use other stopwords dictionary and we use different stemming, maybe these results can change. Okay, nevertheless, this shows a gap that we need to somehow improve the stop word and the stemming methods in Indonesian language. Okay, because the stemming and the stop words obviously are language specific. So we cannot simply apply stemming that works in English, for example, the Porter stammer, to Indonesian language, which I don't think that's going to work. And obviously stop words, it will be like very specific to language. Now, in terms of results from the three methods, okay? So in here, we compare the percentage of accuracy between the three automated classifiers. In addition to the three automated classifiers, we also compare the effectiveness of combining the results of the three classifiers. So in here, we put the fourth mechanism in here, the fourth column, okay? How to get the fourth? So simple. If two of the three method says that a document is like having a positive attitude, then the fourth will say it's positive. If at least two of the three methods say it's negative, then the fourth will be negative. Okay, so in here we also measure the significant difference in terms of variations between the four groups: naive bias, SVM, and decision tree and vote. We use this one ANOVA single factor, and we found that each of these four are significantly varied. Okay, statistically varied. And upon the ANOVA single factor results, we do a follow-up using t-test paired to sample means with alpha less than 0.05. So in here, the superscript signifies that, okay, there is a difference between this one, the naive bias result, with the S is SVM, and V is the vote. So this one is significantly different with this one and this one, the vote and the SVM. All right, from this one, we can see that generally speaking, the SVM produce a more accurate classification compared to the other results. And in many cases, the voting is close to the SVM, and there is no, well, on three of this one, there is no, on three iteration of the 5 iteration, remember that we use k equal to 5, there is no significant difference between classification result by the SVM and the vote mechanisms. So we can consider that of the three automated methods, SVM is better than the naive bias and the decision tree. When we combine the three results using vote mechanisms, the vote mechanism actually perform comparable, or in other words, there is no significance, statistically significant differences between classification results from the SVM and the vote mechanisms. Now, this results is intriguing. So we analyze what went wrong. What went wrong? To do so, we look for feedback where all of the three automated methods fail to accurately classify the feedback. Okay, so we found that of the feedback, we found that 220 feedback were falsely classified by all three classifiers. Okay, and we found that the reason why all three of them fails to accurately classify is because of these three reasons. First, contradicting statements, where the feedback actually contained positive statements that were considered absent and were expected to be available for to improve the class. Okay, so for example, in here, if somehow the feedback is, say, lecturer can explain clearly. Okay, so this is confusing. All right, does it mean that the lecturer cannot explain clearly, and therefore the students providing feedback so that the lecturers to explain clearly? In a sense, if you explain clearly, then it will be better, and that's the feedback. Okay, and that's difficult even for human. It's very difficult to know whether the students is actually expecting the lecturer to be clear in explaining, or the students already think, okay, I'm happy because the lecturers already explained clearly. Okay, so this is hard. Okay, this is hard. The second reason is multiple sentiments. In here is where the feedback contains both positive and negative. Okay, it contains both positive and negative. And finally, this is interesting. Actually, the third one is inaccurate manual label. This is where human label is wrong. Remember, we have to label over 1,000 feedback. Okay, of course, sometimes we make mistakes. In here, the human label is proven to be wrong, and the automated classifier is actually correct. So in this case, the automated classifiers are actually perform better than the human. All right, these are the sample of feedback where all three classifiers are inaccurately classified the feedback. So for example, multiple statements. Okay, in here it says baik dan perlu ditingkatkan. This means the first one is said, okay, it's already good, but on the second one it says it needs improvement. What does it mean? Okay, it's a bit confusing what the student means in here. He said it's good, but it needs to be further improved. Okay, so it's a bit fake. Okay, and inaccurate manual label. It is said here everything is available in the online platform, and then the time is like on time. Okay, in here for some reason the manual says positive and the automated classifier says negative. So if we look carefully in here, if we think this one as a feedback, meanings the students is actually expecting the materials to be available in the online platform and the schedule to be on time. All right, the class to be on time. So that is expectations. If we consider that as an expectations, meanings currently the student think, okay, currently the class is not on time, and currently the materials, the lecture materials is not available in the online platform, and therefore actually the student is disappointed and expecting that this to be happen, and therefore the correct one for this one is actually negative, which is correctly classified by the automated methods. Okay, lastly, in conclusions, we found that current automated sentiment classifiers can actually accurately classify intent within a text. On average, even the least classifier correctly classify 82% of the feedback in our data collection. So that's quite high. Okay, so 8 out of 10 correctly classified. The SVM classifier, support vector machine classifier, perform statistically significantly better than the naive Bayes and the decision tree algorithm. Next, we found that actually the text preparation method, which are the stop words and stemming that we consider in this study, made all three classifiers generally less accurate. So we will need to evaluate the use of these two, or Alternatively, we can also consider to use or even create a better stop-word dictionary and stemming algorithm for Indonesian language. Finally, we found that combining results from the three classifiers using vote mechanisms produce results that are comparable accuracy as the SVM. So we may need to consider another method to somehow combine results of the three classifiers. Thank you. I hope this will be interesting. If you have any questions, feel free to ask.
Dear colleagues, I am very happy to present you my topic called Recent Advances and Application of Selective Laser Melting Technology in Aerospace Industry. My name is Anel and I'm a second-year student, master's student at Nazarbayev University. It's located in the capital of Kazakhstan, Nur-Sultan. So let me present you. Here's my outline of the presentation. First of all, I'll introduce the paper with briefly information and go through the background information. Further, the review of the latest studies summarized in the main three sections. As you can see, there are potential application of selective laser melting in the aerospace industry, key requirements of selective laser melting fabricated parts for aerospace applications, and mechanical properties of aerospace components printed by selective laser melting technology. Then I'll discuss the overall advantages of selective laser melting in the aerospace industry, and I'll discuss the future scope based on current limitations, and after this all, I'll complete the presentation. So let me introduce my topic. Selective laser melting technology in the aerospace industry. Aerospace component manufacturing technologies are all targeted at rapidly improving the efficiency and quality of parts from their design to manufacture while reducing the cost of manufacture. Selective laser melting is an additive manufacturing method that uses a layer-by-layer process for producing complex metallic components in medium quantities. It's a freedom fabrication process that can produce components with diverse metallic materials such as titanium, stainless steel, aluminium, nickel-based alloys, and other powders. By adapting selective laser melting, manufacturing existing designs are produced according to demand, and new improved components can be manufactured rapidly. In traditional manufacturing processes such as milling and machining, the components are produced by removing up to 95% of expensive raw material. So in contrast, additive manufacturing material wastage is minimized by building up a component from the optimal amount of powder and reusing the unused powder. So components can also be designed to be manufactured together as a single part, therefore avoiding assembly and the use of joining technology. Consequently, selective laser melting manufacturing has potential to be faster and cheaper than conventional manufacturing processes while producing lighter components. So in this literature review, the potential application of selective laser melting in aerospace engineering is assessed considering materials analysis and quality of selective laser printing parts in terms of changes in the microstructure after printing. Printed selective laser melting parts are compared with the monolith states in terms of tensile and compressive strength, hardness, wear resistance, and ductility. So the hypothesis of this review paper is that selective laser melting technology will be fully replace many of the traditional manufacturing methods in the future when the repeatability and consistency of selective laser melting will be achieved, as well as interfacial defects will be eliminated, which adversely affect the quality of parts and lead to catastrophic consequences. Next slide considers background information about selective laser melting working principle. So figure 1 illustrates the concept of the selective laser melting building process, and during the SLM process, the building platform is often filled with nitrogen gas or argon gas to provide an inert atmosphere to protect the heated metal parts against oxidation. On this slide, you can see the SLM printing machine. So the SLM process consists of a series of steps from CAD data preparation to removal of fabricated component from the building platform. Before the CAD data are uploaded to the SLM machine for production of components, the STL files have to be processed by software to generate slice data for laser scanning of individual layers. The building process starts with the laying of a thin layer of metal powder by a roller on a substrate plate in a building platform. After the powder is laid, a high energy density laser is used to melt and fuse selected areas according to the process data. Unsettled surrounding powder is used as a support structure to keep the geometry of sintered part. Once the laser scanning is completed, the building platform is lowered by a fabrication piston. The next layer of powder is deposited on top and the laser scans a new layer. The process is then repeated for successive layers of powder until the required components are completely melted. Next slide considers methodology of this paper. So first is search criteria. All data were extracted from the specific science databases such as Google Scholar, Scopus, ResearchGate, Elsevier, and Science Direct. All of these sources have readable articles where it's possible to subscribe to updates of colleagues and additive manufacturing, so the latest reference will be accessible to study. Furthermore, technical reports as well as PhD dissertations that were done in this field could also bring information of practical value, and they were also used during writing this paper. So inclusion and exclusion criteria, additive manufacturing application in the aerospace industry is a broad topic. This paper will focus on SLM-based aerospace components and exclude any study where other methods of additive manufacturing are used. As technology is progressing day by day, the relevance of articles is assessed by the date of publications. So this review will focus on the articles published in recent years, and the ones published more than 10 years ago was excluded from the literature content. So here starts my literature review. First topic is potential application of selective laser melting in the aerospace industry. Selective laser melting has broadened its range of application in various fields due to the huge number of advantages over conventional manufacturing technologies. One of the major benefits of selective laser melting is that it can create complex shapes with reduced time and cost. This revolutionary technology has many abilities that makes it superior over other manufacturing techniques, and these advantages are listed on this slide. First is that SLM can easily cope with intricate shapes. So SLM provides infinite design freedom due to its layer-by-layer nature and control of the process parameters. Furthermore, as components applied in the aerospace industry have complex shapes, so the SLM technique can also reduce the assembly cost. For example, the traditional fabrication of combustion chambers for gas turbine engines can take more than 25 steps to manufacture. Functional efficiency for the combustion chamber relies on its design, its surface roughness, as well as its material and mechanical properties. Usually, the combustion liner tends to be manufactured over a period of time ranging from 5 to 8 months, and all in all, it can take more than 25 steps to assemble each chamber out of 6 plus single components. So now, the flexibility of 3D printing makes it possible to create these chambers in a one-step process. Using SLM on a powder bed, a combustion chamber only requires 45-65 hours of build time. So next advantage is reduced tooling. Single stage and near net shape nature are the key features of additive manufacturing technologies, which exclude the application of a multi-stage tooling. Moreover, the fact that SLM doesn't require support structure while printing means that it will not be removed after the printing, which consequently reduces the lead time in tooling. However, SLM built components still require post-cutting components of the building substrates, removing supports, cleaning, powder, and surface post-processing. There are cases when ideal surface finish is required, when the quality of assembly depends on the surface of finishing. In such cases, post-processing works are needed to eliminate the surface roughness. So the next advantage is less time and reduced cost. The previous features, as it was stated, unintentionally lead to the reduced lead time and cost. Also, since SLM doesn't require expensive and special tools such as molds and dies, this provides technological capabilities for fast and cost-effective manufacturing of 3D parts in small batches. Previous research has shown that small batch selective laser melting has been shown to reduce delivery schedules by 5 months and save up to 30% in costs. And that's just the fabrication stage. Applying this technology to the design and prototype stages allows for much more rapid iterations of components designs, thereby compounding the benefits of 3D printing in aerospace applications. Third advantage is that it has better mechanical features. In selective laser melting technique, the post-process associated with high cooling temperatures and provide enhanced mechanical properties in terms of refined microstructure of printed parts, in comparison with components fabricated by traditional subtractive methods. And the last but not least advantages of selective laser melting in aerospace industry is that this technology is environmentally safe. Additive manufacturing methods, especially selective laser melting aerospace components, are designed to reduce fuel consumption for economy and environmental concerns. In addition, selective laser melting uses less energy for fabrication and is defined as a green technology with lower CO2 emissions compared to traditional subtractive methods. Next slide is key requirements of selective laser melting fabricated parts for aerospace applications. First is the level of densification layer. So the densification layer is a characteristic that directly affects mechanical properties of printed parts. Regarding the layering nature of additive manufacturing technologies, it gives both advantages and disadvantages. There are many risks that can be caused by SLM nature, such as lack of melting, incomplete laser penetration, spattering, keyhole effects, powder evaporation, thermal stresses, and gas entrapment. These limitations are the main causes of defect formation. All of these issues could result porosities and cracks, and it can adversely influence the densification level. Localized heating and cooling in post-processing techniques can cause the defects different from those observed in traditional fabricated parts. These defects are unacceptable even in negligible amounts because defects in aerospace components can lead to catastrophic consequences due to crack nucleation sites initiated on the defects during pressure. According to previous researchers, the relative density of selective laser melting part made of aluminum is 94%, which is acceptable for aerospace applications. However, densification is sensitive to any exterior changes and could not be uniformly distributed along the whole printed part. That's the main limitation emerging in selective laser melting application in aerospace industry. But however, there are sufficient studies optimizing process parameters and utilizing different post-processing techniques that help to solve the density problems of selective laser parts by eliminating defect formation. So next slide will concern surface quality. So surface roughness is known as one of the limitations of selective laser melting technology caused by layer nature. Especially in components with complex geometry, surface roughness is low due to its difficulty to machine. Partially melted powder particles or even unmelted particles, boiling phenomenon, and stay-step effect are the most frequent factors defining the surface quality of the printed component. In general, additive manufacturing parts should experience post-process surface finish, such as machining, grinding, or chemical polishing, to be applicable in aerospace industry. Recently, experimental studies were done on the influence of process parameters and heat treatments on the surface quality of selective laser melting fabricated samples. The important conclusions are as follow. First is that variations in surface roughness observed, which is due to the inherent random errors of the manufacturing system. Second, the surface roughness is increased with increasing with the laser power level, and the best results depicted at 0.32 kilowatt laser power. Third is that the average surface roughness of most of the samples are 77%, decreased after solution heat treatment at 540 degrees for 2 hours. However, after artificial aging at 155 Celsius, for 12 hours, initially at 530 degrees Celsius for 2 hours, the surface roughness increased. And the last is the process parameters. 0.32 kilowatt laser power, 0.6 meter per second scan speed, 35% overlap rate, and 88.7 nanometers hatch distance determined as an optimized parameters for best surface quality in as-built condition. The surface roughness can be further decreased by solution heat treatment at 540 degrees for 2 hours. So next slide is about strength to weight ratio. The principle of having a high strength to weight ratio is to use less material or materials with a low density, but still provide the same or improved mechanical characteristics. Conventional way to obtain lightweight construction for aerospace components is to apply lightweight materials with a high strength property, or optimize the structure of lightweight materials with appropriate manufacturing methods. Also, materials, especially aluminum alloys, continue to be the dominant materials in the aerospace industry. Composite materials are gaining increasing interest and competing with aluminum alloys in many novel applications in aerospace industry. Materials with high strength mechanical properties with relatively low weight is known as the best strategy to improve fuel efficiency and get closer to the green production of aerospace components with low CO2 emission. The general commercial materials used in aerospace industry are aluminum alloys, titanium alloys, high-strength steels, and composites, which typically account for more than 90% of the weight of an airframe. So this slide will concern wear resistance. During the whole life cycle, most of the aerospace components such as shafts, valves, piston, rods, and bearings are generally exposed to wear. Therefore, the material of these components should be selected taking into account wear resistance. Selective laser melting printed parts from metal matrix composites demonstrate better wear resistance in comparison with monolithic counterparts. The wear characteristics of selective laser melting composites depend on the size, concentration, and type of reinforcing particles. According to previous studies, selective laser melting process titanium and aluminum composites demonstrated lower wear rate and coefficient of friction than the monolithic aluminum and titanium parts. Furthermore, studies done by several researchers state that there is a remarkable dependence between wear resistance and the size of reinforcing particles. So it means that higher wear rate and coefficient of friction were observed in metal matrix composites with relatively coarse reinforcing particles due to the low densification level and the structural inhomogeneity. Also, partially melted or unmelted regions of metal powder directly influence on the interfacial bonding and negatively affect on the wear resistance. All in all, high densification level, enhanced microstructural consistency, and improved hardness with relatively fine reinforcing particles as a key strategy to obtain better wear resistance for metal matrix composites. This slide will concern mechanical properties of aerospace components printed by selective laser melting technology. Metal matrix composites is a material combined with at least two constituent parts, one of which is being a metal and the other is a different metal or material such as ceramic or any other chemical compound. In comparison with traditional subtractive technologies, SLM technology produces components with enhanced strength and acceptable ductility from MMCs. There are many previous studies comparing the strength and plasticity of aluminum and titanium matrices with components produced by conventional methods. According to results, the strength of selective laser melting printed titanium and aluminum parts was significantly higher than their monolithic counterparts. Furthermore, the results have shown that the inclusion of reinforcing particles into a metal matrix increases the strength of the parts while decreasing its plasticity. However, recent studies have shown an increase in the strength and ductility of selective laser melting metal matrix composites. So it's well known that the main goal of composites production is to enhance mechanical properties, and one of the main properties of aerospace component is the hardness of material. In this state, selective laser melting technology can increase hardness by up to 200% by improving grain refinement and increasing residual stress. Metal matrix composites deposited by selective laser melting technology present extraordinary features such as high strength at elevated temperature, improved hardness, better fatigue, and creep characteristics in comparison with traditional fabricated counterparts. It makes them potential candidates for advanced technological applications in aerospace industry. So next slide is discussion and future research direction. The mechanical properties of the SLM may be superior to those of the original counterparts, but reproducibility and test and standardization are still an issue. Reproducibility problems can be due to microstructural defects caused by raw materials or processes and can be identified in several ways. Also, strength analysis is still an issue due to many phenomena like residual stresses, anisotropy, and porousness. Furthermore, there are very strict testing protocols and certification and standardization procedures before proposing any aerospace parts for application. The certification generally demonstrates the reproducibility of the manufacturing process and the consistency of the quality of printed parts. By the way, process repeatability and quality consistency are known as key challenges in selective laser melting used in aerospace application, especially when produced in high volume batches. Furthermore, the shortage of techniques for verifying the components fabricated by powder bed fusion technology standards relating to the terminology or processing procedures for different metal alloys considerably impede the application of power bed fusion techniques in the aerospace industry. Future research would be extended on this effect of selective laser melting printing parameters variation on the mechanical performance of printed parts. There are more than 100 selective laser melting process parameters, but the key parameters are those which significantly influence on the density of produced parts. They are layer thickness, hatch spacing, and laser power. As laser is an important component of the selective laser melting process, and the choice of the laser source is vital due to the different energy absorption parameters The variation of laser parameters is very important in standardization and enhancing repeatability and consistency. So let me conclude my presentation. According to the studies done, it was found that selective laser melting is a promising design and manufacturing method that can effectively reduce the design constraints imposed by conventional manufacturing methods. Also, selective laser melting manufacturing has potential to be faster and cheaper than conventional manufacturing processes while producing lighter components. The fabricated composites were defined in terms of mechanical and structural properties, meet the requirements of higher space components. Mechanical properties of selective laser melting printed parts were analyzed according to the previous research studies. The results have shown that selective laser melting treated components demonstrated higher tensile strength and ductility in comparison with their monolithic counterparts, and the best results for hardness were obtained by reinforcing the selective laser melting component with ceramic, and high wear resistance was obtained from high densification level and finer reinforcement particles. Furthermore, recent challenges of selective laser melting technology in the aerospace industry were analyzed. In conclusion, in the current state of selective laser melting, with the absence of certification and process standardization, it's not feasible for wide application. When all process parameters are controlled and consistent, the printing process is stable, then only selective laser melting can be considered as a viable method in the aerospace industry. That is all of my presentation. Here's the reference I used in the presentation. Thank you very much for your attention.
Hello, everyone. I will share screen first. The title of my presentation is Dynamic Study of Batch Milk Cooling Process at Koperasi Unit Desa Sai Pujon. I am Rudi Agustrianto. I work with Dr. Pugu Setio Pratomo and Mrs. Endang Srihari. I will give you some brief introduction and continue to batch milk cooling process in detail. I will present result and discussion and finally go to conclusion. This figure shows how milk is collected, transported, and delivered to milk cooling centers in a number of ways, as shown below. Warm fresh milk should be cooled immediately after milking to preserve quality and prevent spoilage. Cooling to 4 centigrade within 3 to 4 hours is essential, but more rapid cooling is much preferred. Normally, milk arrives at the milk cooling centers in the morning or late afternoon or early evening. Therefore, batch milk cooling are performed as such in cooperatives, for example, Koperasi Unit Desa Sai in Pujon, KUD in Batu, and elsewhere. The main problem that often occurs in dairy factories is the operator's lack of understanding of the process that occurs. This creates difficulties in controlling the process or in designing appropriate equipment when needed. The background of this research is to understand the operation process, which is the overall main goal for developing the process model. The model is often used for operator training, process design, safety system analysis or design, or control system design. So the aim of this presentation is to present the dynamic model of batch milk cooling process. This is the figure of milk cooling system. The first one seen from side, and the second one, milk cooling system, seen from the front. The system being studied is the milk cooling system at KUD Sai Pujon. I will make this presentation quick. The mathematical model for the process can be derived based on energy balance. This is the result. The transfer function TO in S domain per T1 in S domain is equal to 1 per M Cp per UAS plus 1. V is the tank volume in liter. T1 is temperature of chilled water. Ti temperature of inlet milk. To temperature of milk inside the tank. M mass of milk in the tank. This value can be calculated from V and rho. Cp heat capacity of milk. A surface area of milk cooling tank. U overall heat transfer coefficient. Rho density of milk. Q heat release from milk to cooling water. Table 1 shows steady state and parameter data for this research. Volume of the milk in the tank 2,500 liters with the temperature inlet 36 centigrade. We want the temperature 4 degrees centigrade in 2 hours. T1 is the temperature of chilled water 2 centigrade, and this temperature is maintained constant by using refrigerant system. Cp 3.93. This is from the data. Rho 1027 kilogram per meter cubic. M, this value can be calculated from V and rho, and the value is 2,567.5 kilogram. U 274.4613 kilojoule per minute meter square centigrade. A equal to 0.868 meter square, and Q 2,690.74 kilojoule per minute. So we can derive this transfer function from heat balance, and the result is TO per T1 in S domain equal to 1 per 42.3548 S plus 1. 1 is the gain of the process, and the time constant of the process is 42.3548 minutes. This figure shows how the milk temperature varies with time. From 36, it reached 4 degrees centigrade in 2 hours. So what happens if we give step up and down for T1. T1 is the temperature of chilled water. So not constant in 2 centigrade, but we give step up to 12 and down to 7 and maintain constant. Here is the profile of temperature of milk during 2 hours. So, the conclusion of this research, first, the result of the dynamic model of is a first order transfer function, GS equal to TO divided by T1 equal to 1 per 42.3548 S plus 1. The dynamic model of batch milk cooling process has been simulated using Simulink. Overall heat transfer coefficient U was assumed to be constant and could be calculated as the batch process finished in 2 hours. The milk temperature profile shows reasonable dynamic during the process. The proposed model can be useful for control purposes. Thank you. This is my presentation. We can go to discussion. Please, any question, if any? Thank you.
Hello, good afternoon. It's very nice to meet you all. First of all, I want to introduce myself. Myself is Elisa Chandra from University of Surabaya. This time, I will present my paper about student performance prediction in higher education, a comprehensive review. Okay, let me share my slide. This time, I will present my paper about comprehensive review of student performance prediction, especially in higher education. At present, student dropout and retention is a prominent issue in education, especially in higher education. According to Higher Education Statistical Yearbook of 2017 in Indonesia, it stated that about 28.2% students in higher education quit from school. So there are many processes must be conducted to prevent student dropout, such as student performance monitoring, academic rule enforcement, academic improvement, and other procedures. EDM, or educational data mining techniques or methods, can be very potential for supporting university or academic institution goals to improve the quality and efficiency of learning activities and monitoring processes. There are many papers using EDM fields to perform academic improvement procedures. According to Aldoa et al. In 2019, they summarized the previous work in the EDM field. There are three main objectives of computer-based student performance prediction. The first is evaluating learning materials. For example, course content, syllabus, and others learning materials. The second is monitoring learning activities or results, including delivery methods, assignment, scoring, or other learning results. And the third is preventing student dropout. For example, performance measurement, early warning, survival index, and other works. This research is aimed to provide a comprehensive review of recent studies based on student performance prediction tasks and predictive variables, methods and accuracy, and the last is student performance prediction tools. Therefore, this study proposes 4 research questions like this. Question 1 is, what is the student performance prediction task? We focus in the task performed by the previous studies. And the question 2, what are the predictor variables or attributes used in student performance prediction? In question 2, we focus at the predictor variables. Question 3 is, we focus in the prediction method used for student performance prediction. In this case, is student dropout prevention. Question 4, what about the accuracy of each method used? And the last question is, what are the frequently used tools to perform prediction tasks? To narrow the result search, this review was conducted using specific search keyword and criteria like this: educational data mining or learning analytics, student performance prediction, early warning or early prediction or early detection, and other search keywords. And this paper limitation is any studies performed in 22 start in 22 until December 2020. After a strict screening of previous studies, we select only strong related papers, and the duplicate papers were excluded from this review, and it resulting in 34 papers, which each paper can contain more than one research. And we select the articles from reputable journals and conference publisher. Okay, we will talk about results and discussion. Okay, at first I will show the number of student performance tasks. Student performance prediction task is categorized into 5 main tasks. First task is student identification and classification. This is the top one from all studies. And the second is student modeling and enhancement. The third place is early warning and recommendation system, and the last is survival indexing. So we categorize all papers, the 34 papers, into 5 categories. So we know that the top 3 frequent tasks performed by recent studies is student identification and classification, student modeling and enhancement, and early warning. Student performance prediction include in these tasks early warning and recommendation systems. We know that Some student performance tasks is often used to predict student performance, such as identification and grouping students, measuring student performance, for future development, providing early warning, providing recommendation, and presents a student success index. Here, I show you the studies of each task, and now we talk about student performance attributes or predictor variables. Student performance attributes or predictor variables must be analyzed to perform the best prediction. We categorize the student performance predictor variables into internal and external attributes. External, internal. Internal factor or internal attributes is any factors that happen inside the university or belongs to the university, while external factors come from the outside of the university. For example, students' family condition. It is the external factors because it happened outside the university. Internal factors are considered to be more flexible because the university members can change them. The university can change the regulation, rule enhancement, process improvement, and other processes that can be controlled by the university. But the external factors, which cannot be controlled by the university. In this research, personal factors such as behavioral, psychological, and motivational factors are also examined, as well as academic factors. Student performance factors have been already examined in previous studies, but most of them use specific academic fields. Most of all, using academic and internal factor from the university. And the result is academic and personal attributes have a significant impact of student academic performance. However, these studies mainly focus on academic factors. Many researches, many papers include or use the academic factors, mainly focus on academic factors. But studies from student personal approach had been emerged to provide a better representation of a student. The social behavior and personal behavior, psychological factor has examined in the present, resulting it caused a significant increase in dropout prediction accuracy. So if we include the personal factors or external factors, it can be improve the accuracy of the dropout prediction. Next, we will discuss about student performance prediction methods. We can conclude that most widely used method is the first is decision tree, following is naive Bayes and key nearest neighborhood. It is the top three of the method, the top three of frequently used method in student performance prediction. The accuracy result, we see that the highest accuracy is achieved by neural network, and the second is random forest. It is the best result from the EDM method used to predict the student performance. After we talk about the methods, we discuss about student performance prediction tools. Many researchers use tools to perform prediction analysis in EDM. Many of them also combine the prediction tools, and the result is clearly described in the table. There are three objectives: data manipulation, analysis of algorithm data, and data visualization. Many researchers also use Microsoft Excel, EDM Workbench, Python and Jupyter Notebook, SQL, SAP HANA, and ALAB for data manipulation. This is the frequently used tool by the researchers to use or to do the student performance prediction. Okay, the conclusion, this review finds that student academic prediction play an essential role in providing opportunities and solutions to various academic institution problems. Mainly student dropout mitigation. In general, most data mining techniques or EDM techniques are well suited to perform student academic prediction. According to the review result, we suggest random forest, neural network, decision tree, and naive-Bayes method to perform student performance prediction because these methods have high accuracy results. So we will recommend, we recommend random forest, neural network, and decision tree. Furthermore, we find that academic factors are frequently used in EDM fields. Academic factor, because many researchers use academic factors as the predictors with high accuracy. There is still limited research using personal characteristics. such as psychological, social behavior factor to perform student performance prediction. So it needs to be explored in the future. So we hope that in the future, student performance prediction also include the personal characteristic or personal factors or external factors, not only internal factors, but also use external factors, especially personal factors. So the accuracy of the prediction method will be increased, and we hope that with the prediction we can provide the mitigation in the university, and the dropout rate can be decreased because the university management can be earlier, can be recognized with student that must be treat as well, and with student that can be enhance the performance. So we hope that with this review, many other paper using student performance prediction can be increase or attain a better accuracy, higher accuracy. Okay, thank you for the time. And this is the reference. Okay, thank you for your attention.